Mutability. Mutability is an important concept now that we have more advanced data structures. Fundamentally, the idea is whether values of the given type can actually change their inherent value, or if the value cannot change what it is. When we store values into variables, we often need to consider whether that variable is holding a mutable value. Many kinds of bugs can occur when we try to use an immutable value mutably, or a mutable value immutably. Strings and lists are similar because they are both sequences of elements. However, a big difference between them is their mutability. Strings are immutable, while lists are immutable. Integers and other primitive types are all immutable, in fact, while lists and data classes are both mutable. Say you have a string variable. When you add another string to that variable, you need to assign the result, otherwise it is lost. Similarly, when you call a string method, you need to assign the result, otherwise it is lost. This is the idea of immutability. You are never changing the string, you are simply creating new ones. Integers and floats follow the same principle. You cannot fundamentally turn the value 5 into a different integer. You are always creating new integers based on the old one, but you cannot change the fact that 5 is 5. Now say you have a list variable. Appending a value to the list fundamentally changes the list value itself, so that the list has a different sequence of values inside. This is the idea of mutability, the fact that the list itself can change. A tricky thing to remember with lists is that if you append a value to the list variable, you must not assign the result back to that variable, unlike with strings. The append method modifies the list variable and then returns none. So if you assign the method's result, you overwrite the list variable. As long as you don't assign back, the append call will mutate the list, changing the data inside the list without affecting the list variable. Data classes can also be mutated. Anytime you assign to an instance's field, you are modifying the instance. In the example shown, we create an instance of a dog data class and then later update its name field. Afterwards, the name field has a different value. In this way, you can also see how fields are similar to variables. We have seen mutability before when we learned about parameters of functions. Let's take a look at this function addX that consumes a list and a string, and adds the string value x to the end. When the function call is over, only the list has actually been changed. Even though we were using local versions of each variable, the mutability of the list type meant that the original list was changed. If we wanted to change the name variable, we would have had to return the modified value and assign it back to the name variable.